Hello, and welcome back to Pass the Torque. I'm your host, Katie Caudry. This season, we've learned about all things OSAM, or On-Orbit Servicing, Assembly, and Manufacturing, and today we're going to learn about research and development from Dr. Crystal Johnson. Don't forget, you can leave a question for Dr. Johnson in the comments below for a chance to have them answered later this week. Let's go ahead and jump in with the first question. What is your role at NASA? Can you explain what you do?
I'm Crystal Johnson. I'm the Deputy Center Director for Technology and Research Investments at Goddard Space Flight Center. And what I do is I shape the missions of the future in astrophysics, earth science, heliophysics, and planetary science. And then I'm responsible for making sure that we have a really solid technology portfolio that is matured in time. All these technologies have to be developed and matured in time for us to be able to infuse into those amazing missions of the future.
Can you tell us about your background?
My background, I started in laser design and development at Langley Research Center. So I was developing a chromium lysaf material. We were looking for new materials that we could develop into lasers, and these lasers for remote sensing of the atmosphere. And so that was the start of my career, but I went from that to being the deputy for our electro-optics and controls branch. And then I was responsible for all of the laser activities going on at Langley Research Center. We had multiple projects going on, but I was the one that interfaced with headquarters to get the funding for all those different projects, and then distributing the money across the different organizations at Langley. Then I had a wonderful opportunity to go to NASA headquarters. I was the associate director for all exploratory missions. So any mission where you're probing the Earth to answer a specific question were my responsibility. So I did a lot of international work with lots of different countries, spent a lot of time at Jet Propulsion Laboratory, a lot of time at Goddard, looking at all the projects that were under my responsibility. And then we had the Columbia accident, and we knew that we were doing a horrible job. We had been told by the Accident Investigation Board that NASA was doing a horrible job overseeing the engineering for our agency because it was just an advisor position and there were 5 people on his staff. So they asked to stand up this new Office of the Chief Engineer. The Chief Engineer at that time asked me to come up and help him stand up a whole new Office of the Chief Engineer. So I did that, and I became the Deputy Chief Engineer at NASA.
What does the research and development process look like at Goddard? Can you walk us through a project from start to finish?
Yeah, so research and development, there's no research and development project that's exactly the same. Everything depends upon the state of the technology that you're trying to develop. For me, when I was at Langley Research Center, and the way that it is for many at Goddard, you actually start going in the laboratory. You have this idea that you want to test out. And for me, I was trying to come up with these new crystals that we could actually formulate into a laser material. So you go in the laboratory, you get the material fabricated, or whatever device it is you're trying to create, you piece together a laboratory version of it. Then you test it out in the lab to see if it works. Then from there, you can actually start developing a protoflight type, one that is very close to a flight version of it, but not necessarily flight, because flight requires you to have specific soldering, specific parts, specific testing, all of that. So you develop the next to flight version of it. And for us, we would do it piecewise. So you do a laboratory version, and then we do a version that we could fly in an aircraft. So that you could actually test out the capability, make sure that it measures exactly what you want it to measure in a very close to space kind of environment. But for us, it was just on an ER2 plane. So for earth science measurements, you can fly it in an aircraft first and see if it's going to make the kind of measurements that you'd like for it to make. Once you get all of the bugs worked out of that, then you prepare for a space qualified version of that. And then by that time, you think it's pretty close to being pretty sure that it's going to perform the way that you want it to perform. So it is a stepwise process that's required. One of the few places anywhere where you have complete end-to-end capability, all the way from coming up with an idea, crazy idea, to going in the laboratory and building just a prototype, and then being able to build a flight version of it and do all of the testing right there on site. We also have a range, so we can launch our own things from Wallops Flight Facility. And then we have amazing scientists and engineers who can develop these algorithms to take the data, once you're up there and collecting that data, transition it into something that's applicable to real world improvements and real life improvements. So I just love the opportunity to be at Goddard, and I've been so happy to be a part of this amazing team.
What is the end goal for research and development?
Research and development is always, you start with a concept and the end goal is always to be able to apply it to make the actual final measurement. So whether you're coming up with a new detector that you want to sense, exoplanets, a long way away, the ultimate goal is to be able to get that device measuring it and to make that measurement and be able to have the data the data that comes from that measurement come back and inform everybody. So at Goddard Space Flight Center, we are a majority science center. And for us, the most important thing is for us to be able to get the science data back down so that we can apply it to our knowledge base to improve on whatever knowledge we have. So the technology development, there have been lots of debates about when you do technology development and getting funding as a part of a project for technology development. But one of the lessons that we've learned over many, many years is that it pays significantly for you to develop the technologies before infusing them into actual missions. Because if you run into problems, the cost for the mission goes up and up and up, and you never know when you're actually going to get your arms around it and fix the problem. So the technology development is a very important part for us as we're developing the missions for the future. But then once we get the technology developed, it's not a matter of just infusing it into that one mission and being done with it. For us, it's really important for us to transfer that technology to industry, for them to be able to commercialize it and be able to fuel the economy and make more from that technology than we even envisioned when we first developed it. Many times we find that you start with one particular application in mind, but then the benefits of that particular technology can go into a different field, and you can make a revolutionary change to the way that they're doing something in a whole different field. So that's exciting. That's one of the real exciting parts of technology development.
How does Goddard decide what projects to pursue? What is Goddard's long-term strategy?
Yeah, so Goddard is a science center. And so the great thing about science, we are one of the only organizations that has a full capability and a full deep bench in all 4 science divisions. And so that's astrophysics, earth science, heliophysics, and planetary science. We are the largest portfolio anywhere for heliophysics, studying the sun. And so the great thing about science is we have these decadal studies, and the decadal studies are not even done by NASA. It's an independent look involving experts from all over the world, and especially, involving academia, involving private industry, involving some NASA employees, but they kind of take a look at what are the next measurements that need to be made, not just today, but way down the road in the future. And so when they come up with their decadal priorities, we take those decadal priorities and we think about, all right, if they say we need to make this measurement, we think we can make that measurement by using this kind of instrument, using this kind of platform, and whatever else. And so we build our missions based upon the priorities that come out of those decadal studies. And so you can make a measurement multiple ways. And because we are one of the largest groups that can perform all of these different things, we have partners that come to us from academia, from private industry that want to partner with us. So we end up having multiple proposals for one target area. Let's just say we want to go to, Europa to make some measurements in Europa. There may be a couple of different people that come to us with an idea of measurements that can be made on Europa. And that's if Europa is a priority, we'll say, for that comes from the decadal. We really have to kind of look at several different factors that go into us making a decision which of those we actually choose to work on and that we choose to put a proposal forward on. A lot of it depends on team members, who's a part of that team, what kind of measurement or what instruments are they using to make that measurement, what is the total concept. How feasible is that concept? For that concept, how many technologies will be at a technology readiness level of a 6 before you even get to PDR? And there's so many, there are like 100 different factors that you could consider. But we have a way of looking at all of those different factors, putting them together, and determining which ones we think have the highest probability of being successful in the review process at NASA headquarters. And we go with those. And so we don't, since we have so many scientists at Goddard, we don't get into the business of saying yours is going to win and yours is going to lose, because we're not the selecting official. The best thing that we can do is put our best foot forward with the things that we think have the highest probability of being successful. And whatever the target is that SMD, our Science Mission Directorate, feels are the highest priorities, those are the ones he's going to pick, as long as they're technically feasible and they're low risk, relatively low risk missions. And so there are a lot of different factors that go into it, as I said. Yeah, I mean, we do a lot of that kind of work here. So if you think about the spacecraft that have flown right now, when you turn on the news today and you look at the weather, those weather forecasts that you get, NASA has developed, or Goddard Space Flight Center has developed all of those platforms that NOAA uses to be able to tell us what the weather is. Not a single one of those have been done on the domestic side. We are the ones that are doing those for NOAA. So every day when you turn on the TV, that's a great example of how we have been helping to improve the quality of life. You think about all of the data that's come down from the International Space Station, all of that's come right through Goddard Space Flight Center. That's a huge amount of data and a huge accomplishment for our center. And there are so many different things that we do on a day in and day out basis that are very, very exciting.
What are some cool things that Goddard does that people might not be aware of?
Well, I will say one of the coolest things that we have done is we have a search and rescue beacon that we have developed at Goddard Space Flight Center. I don't know if many people know about that, but that search and rescue beacon you can actually use the satellites to triangulate a single ping, single signal that comes from that search and rescue beacon, and we can find you wherever you are on this planet. That is an amazing capability. It's now being used to also help with the search and rescue capability for our astronauts. It's being used, it's saved hundreds of thousands of lives since we actually put it out. For people who go hiking and end up getting lost, they can use their little beacon to send us a signal, and we'll be able to find them. People can use them when they go out in boats on the water, and so many different applications. But that's probably one that most people weren't even aware that's happening right within the gates of Goddard.
What is an exciting technology that was developed at Goddard?
There's so many different technologies that we've developed at Goddard. The search and rescue beacon is my favorite, absolutely, because it is affecting lives every single day. And without it, so many people would be, they'd lose their lives. And so that is a very important technology. But we have the core flight system software as well. So when you're talking about command and data handling for spacecraft, we have developed a modular platform that you can actually make changes to one specific element of it. And it's open source software now. It's been offered to the public. And we're finding that companies that are building spacecraft are using Goddard's core flight system for all of their command and data handling capabilities. So you can make a change in one section, test it out on the platform, make changes to it without having to reboot the whole system and without having to start from scratch. So it's saving these companies tons of money. And every time we come up with a new mission, we've already got a system in place and something that you already know what the connections are for all of it, saving money, saving requirements, and everything else. So that kind of software development that we have done has been top notch, and not just used by NASA and some of the companies that are providing spacecraft. Even other agencies, other space agencies are wanting to use our software.
What are you most looking forward to at NASA in the next few years?
I think, well, so one of the things that I'm really looking forward to, as I mentioned, is actually being able to see us put a woman on the surface of the moon. For us to be able to test out so many technologies and capabilities on the moon in preparation for us going to Mars, that is going to be amazing. And for us to be able to have a sustainable presence on the surface of the moon where you're not just coming back and forth, but having people live on the surface, learning how to live on a whole different planet that's not in an International Space Station, this is going to be absolutely amazing. And just think of all the innovations that we have come up with just for us to be able to go from Earth to the International Space Station and back. With all of those developments and amazing technologies we've brought to bear, imagine what kind of new innovations there will be when we have to create something from nothing. We have to learn how to develop our own food and make sure we have clean drinking water and, you know, make sure we have air that is going to be sustainable for us to be able to live, you know, with. Those kind of things are amazing. For us to be able to go to the moon, we've got to create suits that can protect humans from the amount of radiation that they're going to experience on the journey. And it's a long journey going to Mars from Earth. And so there's so much that still has to be uncovered. And you think about the thousands and thousands of technologies we developed that are now improving the quality of the quality of life, like the jaws of life that we had to develop for the International Space Station, where you could actually cut metal with one person doing an extravehicular activity. They're going outside of the space station, and one person alone has to be able to cut metal with no gravity to help that. We came up with the jaws of life, and the jaws of life are being used now when people have these horrible accidents and their cars are mangled and people are trapped inside the car. They use the jaws of life to cut the roof off of the vehicle, and they can pull those people out. We've done things like even things that are not, you know, as detrimental as something like, you know, somebody trapped in a car. People like Speedo, the company Speedo, came to NASA and said, hey, you know, you guys do a lot of drag and friction reduction in your wind tunnels. Could you help us reduce the drag for swimsuits? And we said, of course. And so we worked with them to develop a swimsuit that actually reduces friction and drag for the swimmers. And the first year that those swimsuits came out, they had 8 world records broken in the Olympics by people wearing our swimsuits. And so, I mean, I could tell you 1,000 of those, and we don't have time for me to tell you 50, because I could tell you 52. But there are so many technologies that we've developed because we had to. And just think of what we'll be able to do in the future.
What do you do for fun outside of NASA?
Well, my favorite thing to do outside of work is travel. I love to be able to go places that I've never been, experience cultures that are different from mine, and just meet people from different parts of the world. It's been very, very enlightening to kind of pick the brains of some people that have very different life experiences from mine. And it's very, very enriching for me. I will say my favorite place that I have been, well, I'll just say because it was just such a wild experience for me. I had a birthday, a big milestone birthday. I won't say which one it was, but 3 years ago, I had a major milestone birthday. And I said to my husband and my son, I want to do something I've never done before. I want to go someplace I've never gone before and just experience something really different. Well, my husband had to work, but my son and my brother decided, they were like, I'm in. Whatever you want to do, let's just go do it. So we bought airplane tickets, hopped on a plane, and went to Dubai. I had never been to Dubai before, and I was like, oh, I'd love to go there and just experience it. So we went. We had this excursion while we were there to do camel riding and do dune bashing. They call it dune bashing. So you're in one of those SUVs and you're holding on for dear life on the top, and you're jumping dunes in an SUV, going out into the desert in the middle of nowhere. So we go out and we're dune bashing, and then we go quite a ways further, and we ended up at this place where they entertain people. And so you do camel riding out there and all. So I went and hopped on a camel just so that I could take a picture, and the gentleman surprised me, and the camel stood up, and we're, you know, walking on the camel riding at nighttime, which is scary to me because I wasn't, camels are tall, much taller than horses. And so you're way up, you don't know what this camel is going to do. And I'm recording myself, the dancing and all of that, the belly dancer and the male dancer twirling around and all of that. So it was just a really neat experience and something cool to do for a birthday.
Thanks so much, Dr. Johnson. And thank you for tuning in to another episode of Pass the Torque. Don't forget to drop a question in the comments below for Dr. Johnson for a chance to have them answered later this week. We'll see you again next week for another brand new episode of Pass the Torque.